Everybody have it? Okay, good. If you have it, then it's cloned on everybody else's. All right, so we're going to open that file, and we're going to look at that file. Is everybody okay with this idea? All right, so here's what you're going to do. That's the file we're going to go, so I'll walk you through it. Yep, I'll walk you through it right now. We'll do it. See that on your desktop, FTK Imager? Double click and open FTK Imager. And it will look like this. Everybody this far? You guys good? FTK Imager? Okay, now we're going to open that file. So we're going to say File, Add Evidence Item, because FTK is Forensics Toolkit, so we're calling it Evidence. So Add Evidence Item. Then it's an image file. It's not a physical disk. We already, made it an image file. So say Image File and say Next. Now the file is in the folder C, Data Recovery Software, Student CDs, and then you'll see the Kingston Media Traveler. So it's in this folder, C, Data Recovery Software, Student CDs, and then if you click that folder, you will now have Kingston Data Traveler, and you can hit Open. It's right here. It's C, Data Recovery Software, the same one you've been copying. And then under that, Z, Student CDs. And then in that folder, there's one called Kingston Data. Everybody good?
Kingston Data Traveler. Okay.
Yep, that's it. Okay, everybody good? Good. All right, you can open it. So go ahead and hit OK and open it. And then say Finish. And now it will add it. And if you expand all your little pluses, you will see that it actually has data on the disk. You see that? Everybody good? Okay, so you actually have a whole file system. Everything's there. This is a forensics tool, so it has some other things that we're not really going to use here. But like, for instance, this is a slack space and stuff like that, which is leftover space on the drive in between file names. What I want to do is, if you're looking and you highlight the top item, which is the actual whole disk, which will be the data media. It will be the entire hard drive. Okay? Everybody see that? If you click the top one. Now, if you scroll down in hex over here on the side where you're actually seeing the hex editor, you see right here, it says 55AA. So what is this first sector? Yes, it is a partition, and it is NTFS. So it's NTFS, and it's on a thumb drive. So bad things happen on thumb drives, okay, with NTFS. Now, what I'm going to display to you is at the beginning. So when you have a JPEG, for it to be a file, it must begin at the beginning of 512 bytes. Okay? So if that's the beginning of 512 bytes, if you had one and it started over here, then that might be a JPEG embedded in a Word document or in something else. So if it's a file by itself, then it will have it'll have a signature right here at the beginning of 512 bytes. And then that will be for each cluster until there's some remaining space, and then there'll be some free cluster space at the end of that. So I don't want to get too deep into that because there is some specific things about memory and clusters and slack space, forensics topics. So this is what I want to do. I want to find a JPEG. I'm going to show you how carving works. So in this box, just click somewhere so that you're in this text box somewhere. So your cursor is blinking. Everybody good? Mm-hmm. Hit Control F as in find. Okay? Now, we want to find a picture. Now, I know a picture, if it's a JPEG, starts with FFD8. If you did not know that, if you said, I want to know if there's a picture on this hard drive, go to Google and type in header JPEG, and it will tell you FFD8. It is in the book. There is a picture. I have it in there. I don't want to jump ahead because that's later today, but that's what we would be looking for. And it would be in hex. I don't know why they say binary. It's not really binary. It's hex. So click this button here that says hex. The beginning of a JPEG will be FFD8. So that's what I want you to type. Okay? Everybody got FFD8? Did I get 2 F's in there? Shoot. Okay? FFD8. Everybody good with this? All right. Now click Find. Now, what we're looking for is an FFD8 that starts at the beginning of the dotted line, which we happen to find one, right? So at that dotted line, we have one. So now if we had one that was wrong, it would be called a false positive. But since we have one that's real, that's what we want to use. A false positive would be one that is not really a JPEG, but does start with FFD8, but doesn't belong to a JPEG. It could be something else, because anybody can write whatever they want. All right, everybody good? Now, is this really a JPEG?
Looks like it.
Yep, looks like it's really a camera picture, right? Because this is the XIF data. The XIF data is the date and time, the Canon power shot that shot it, and then after this, there's going to be some other data. There's also, in some pictures, can be a thumbnail. So you can have a thumbnail and a picture in the same thing. So you can have a little mini JPEG and a real JPEG together in the same file. Okay? And then you have thumbnails in a DB database as well. So there's some other stuff we can find. Everybody good with this concept? Now here's the thing. This tool is terrible. It's good for you to just quickly view stuff for free because this tool is free and parses file systems and things like that. But it's terrible at marking data. If you really want a real hex editor, then you use 010, X-Ways Forensics, or go find one and download one. We're using some cheap, crappy stuff to find something out in an instance. If I was doing this remotely and I had no option that was free, then I would just go to access data from the remote machine and download this tool so I could see it. And this will let me image things and let me check on things. So what I want you to do is, right before the FF, I want you to click right before the FF so that your cursor's in front of FF. Okay? Everybody good with this? Now you need to be really careful with what I'm going to tell you, not because it's going to delete something, but because it's going to take you time to do it. We're going to hold down the Shift key, and we are going to page down, I'm going to say 50 times. Okay, so you got to count really quick. So hold down Shift, and you're going to page down 50 times. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. Okay? All right. Okay, and then just stop and just let go and don't do anything. It should still be blue. Right? Don't click on anything, don't move. Otherwise you'll unhighlight what you just did. Everybody good? So this is what carving does. Carving would search for FFD9. It would be looking for the end of the file. The end of file is FFD9. It doesn't care what's in between there. It's just carving FFD8, FFD9. And it's just highlighting all of this content and writing it out as a separate file. That's all it's doing. It's not doing anything special, anything different. Understand? There's no file name. There's no dates and times. The dates and times are XIF information. It's part of the file. It's not part of the file system. Everybody good? You guys good? Good, good, good? You got this? Blue? It doesn't have to be at the same spot. Don't worry about it. No, that's fine.
Okay.
That's fine. You good? Fine. All right. Now here's what I want you to do. Carefully right-click in the blue area. So go up to the blue area and right-click. Then I want you to say Save Selection. That one right there. Save Selection. Okay? Now hit the button that says Desktop on the left-hand side. And then I want you to call this JPEG Test. .jpeg. So it's going to be JPG Test .jpg. That's what I want you to type. Just like that. JPEG Test .jpg. You guys good? So when you hit save, go ahead and hit save. Now, don't touch anything else, just shrink it down. Shrink the window down. Okay? Shrink the windows down so you can see your desktop. And you should have your JPEG test on your screen. Do you guys see that? You have your test JPEG on there, or whatever you have. What did we make it? JPEG test? I got the wrong one. I call it test JPEG or JPEG test? There it is. Here's mine. So there's mine. I had another one. All right. If you double click on it to open it, you should get something at the top. We did not get the whole picture, obviously, because we did not know where FFD9 and FFD8, the beginning and end, were. We could have marked them if we had a really good tool, but we don't have a really good tool. Otherwise, it would just search forward. Does everybody have a little bit of this?
Tiny bit.
Mine is this.
Yes, right. It's very tiny. A little sliver. And we could always do more, but you could tell this is actually a picture. If you could see enough to tell it's a picture. Everybody else kind of see? Yeah? There's a little sliver. Now see, yours maybe didn't get 50. And so it only has the dimensions. It doesn't have the rest of it. So maybe didn't get 50 or more. Like if you have enough of it, it'll show you just enough. If you don't, yeah, it'll just be, so that's all it's doing. It's not doing anything else. That's all it's doing is trying to carve that little chunk. And once you have enough that it can process, that's what happens. So I had a little bit more than you guys did because I counted. So at least at this point, you can tell it's a real JPEG. I really have something. This is a great picture. This is a great test to see if a RAID array has anything on it. Because remotely, I can tell without doing any additional work, if there's a JPEG, then I got a good chance I can solve this problem really quickly. Does that make sense? Now I can do other pictures. It doesn't have to be a JPEG. It can be a GIF. It can be a Targa file. If you're working for a movie studio or a video company, it's a Targa file for animations and things like that. CAD drawings, you can do those. You just have to know what those headers are, so you have to go look them up. So this is what the automatic software is doing for you. Okay? So that's just enough for us to be able to tell that that's the case. Everybody all right? So this is what happens when it works right. You can close this. You can close that, and you can close all of this now. You can close that file as well. So just close everything so we're back to nothing. So now I'm going to show you where you don't see anything and nothing works right exactly. The file system doesn't work. What are you going to do? Now in my example, one of the first tools I use if I'm low end and I don't have any expensive tools and I have to work in $50, one of the tools I would use would be Disk Explorer for NTFS. Have you guys heard of this tool? So I'm going to show you how it works, and then I'm going to show you it fail. I expect it to fail. Then I'm going to show you how to fix a fail. This will be kind of those tricks and tips that you can use along the way. So here's what you do. On your screen, there's a red box over there on the right-hand side called Disk Explorer for NTFS. It's made by Runtime. Everybody good with this? Everybody good? Execute. Double click. Shoo. All right. Now, it's showing me the existing partition for the local drive. So this is showing me my current partition on my current drive. Everybody good? I'm going to show you how it works. We're going to double click on NTFS. So double click on NTFS. I only have one partition, and that's NTFS. Next, you now see we're inside of a valid boot record, and we have content. Now these two are invalid because we don't have additional disks. So we have valid boot record and the invalid. Now on the menu across the top, I can actually parse the data, $MFT and things like that. So if you go to the Go-To menu, these are the records. And you can see MFT, root directory. So I want you to hit root directory because root directory is the first dot that's inside the MFT. That's what it finds, is the root directory. So if you hit root directory, very quickly, it will parse out the MFT entries. Now, it did not touch the rest of the file system. It did not touch anything else except MFT entries. Understand? It did exactly what the Deep Spar was doing when we did that image earlier. It did exactly, it touched just the metadata. So, and I don't want to leave the tool out, but the tool touched it too, right? So you have the boot record, and then the partition record, and then $MFT, and that content was parsed. It did not thrash across the hard drive or do anything different. This would work even if the drive says 55AA or 55BB. If we change it to that, it would still work because the software doesn't care about those things. Only Windows does. Everybody understand? So if I have a hard drive that came in for recovery and I imaged it, I would jump into here and then I would immediately go and say, okay, great, I don't have to parse any of this other stuff. I can come, and this also doesn't have the security problem I can bypass all security so I can get through it really quickly. So I can come down to Documents and Settings. Now if you look, short file name and long file name are both listed. They both have the same record number. You see how they have record numbers? The pairs of record numbers are short and long file names according to the file system. That's what those are. So let's say I click on Documents and Settings. And then inside of Documents and Settings, you will see other content. We should be Administrator. So click on the first one for Administrator, and that's our MFT record numbers. And now you'll see that you have access to all the folders and stuff. You can save a particular folder. If you come over on the right-hand side, you'll see as you go over a folder, you can hit Save. And when you save something, it will save it to a drive by cluster. It actually will convert clusters to LBA blocks and will recover them in order. So when I say save anything, if I said go, it's actually going to convert these by cluster and record number. It is not going to be doing what Windows does where it mounts a directory and crawls all that. It's actually going by cluster and following the cluster chain and recovering the drive. So it's not doing damage to all the other stuff you don't want to touch along the way. Does that make sense? If I was doing this on an original drive, if I'm doing this on a clone, I don't really care, right? But on an original drive, if I had to do this for some reason, this is the part that I'm looking at that's important. Okay? And then you can include subdirectories, and it will export, and it will dump all that stuff. This is what I'd normally do if it's a good thing, and if I'm in a hurry, or if somebody comes in with a payroll disk and says, I have to have payroll tomorrow at noon. This might be a way for me very carefully to go after the original file as quickly as possible. It's not cloning it in the process, though. Okay? Yeah?
So if you're just getting like my document from the user, you just go here and save my document. You get out.
Yes, you don't have to worry about security. You don't have to set permissions. You don't have to do anything. And you'll be able to parse file system stuff and extract it. Now this tool is more powerful than this. You can just happen to be able to extract all this data, but I can also examine the data and fix data while I'm doing it. So there's ways for me to do that, which is why I'm using this tool, because I'm going to show you why it's my kind of go-to tool to start with, because I can also now examine other content. And so for instance, if you have a file, like here's a file, like let's just say the NT user log right here. If I click on this entry, this parsed the MFT entries. You know those MFT entries we were just talking about? So if you look at this, this was the file records are being parsed in the MFT entry data. And inside of there are, and forensics people would recognize these, $10, $30. These are going to be your dates and times in the MFT entries. And so this is called standard information. And then in the body, they actually have the dates and times. When you are, the MFT, when I showed it to you earlier, a little chunk of the MFT entry is the date and time. So if you click on any file, it doesn't matter what file you clicked on, you could go to $10, go to body. And in Explorer, when you open up Explorer on this file, those are the dates and times that are across the top. The time that says creation time, modified. Now modified time, there's an MFT modified time and a modification time. So that would be created, modified, and accessed. You're going to have 3 dates and times. Those are the ones Explorer displays. Okay? That's the data that's in the MFT. That's what it looks like in hex. That's the data in hex. Understand? So if I wanted to look for it, I could go find this in an MFT entry, and that's going to be specific for this part. Now, and then the same thing for these other items. There's a file name, date and time, and body. So there actually is content that's associated with the file name, and this one's a short one. See how this one says file name type 2? And then the next one's going to be a long file name. So that's the Unicode file name right there, number 1, and then there's a number 3 for long file name. And then the body of the data. This contains all the clusters that continued on for the rest of the drive for this data. So as I extract content, it's going to do this in order and follow this run. Does this make sense to everybody? Everybody understand where I'm going with this? So if I had to do something, I'm not going to say you can manually fix this right off the bat here, but I can follow things and find out what's wrong and this also lets me have access to MFT entries that might be damaged. Okay? All right, so let me show you. This is how things work when they work well. Now the back button is this blue button over here on the right. So when you say go back, that's the button. And you hit back and we'll be back to our file system stuff. Okay? And so normally I would go into a recovery that was working. I would click here and I would save the directory for what I needed to extract for the user. That way I don't have to deal with any of the other problems. Okay? Now, I'm going to show you what happens when this does not work. On the menu across the top, File, we're going to open an image. So in other words, I went and I did a recovery on a deep spar, but there's still some corruption. And I can open a drive or I can open an image. I happen to have image files on here, but you could have said drive. It doesn't make any difference. We're going to open an image file that I copied so that we could put these on the laptops. So hit Image. Now I want you to go, if you go down through C, you will see Data Recovery Images. So you go to C, you go to Data Recovery Images, not the software, the images. There's one called Data Recovery Images. Inside there's one called NTFS. And inside there's another one called NTFS Quick Scan. When you're finally in that folder, change the little drop-down box to All Files. Because DD images have numbers of names, and so this particular one is actually called the DD image, but they can also be called IMG or a number of bind, DAT. There's a lot of different ones. So you do the little drop-down box that says All Files, and then you highlight the one called NTFS Quick Scan. You see that? Yeah. Okay, everybody good? Good, good, good. Okay, go ahead and select it and say okay, open. So when I do that and I say open, you're going to see, oh look, I have NTFS in a partition. So I have a partition table and an MBR. So it knows I have that, right? You can even see, like it says, okay, fine, blah, blah, blah. I know what this is. Starts at sector 63. I know what type it is. So it's NTFS, which is 07. All right, so we're going to double click on NTFS. Oh no. I think I died. Did everybody else's work? Did it? Okay. Yeah, maybe, give me a second. Shua. Okay, so now everybody got here, right? And you see it's corrupt. It actually says it's invalid. But if you look at the go-to menu, the stuff we just did a minute ago, we can't do. It's not going to parse the structure. It can't find the structure. It doesn't know where the structure is because the pointers are corrupt. There is damage on the disk. Okay? So my problem is this is really kind of a really good go-to tool and I can parse and do some things. So what I really want to do is I want to figure out ways to get around the problem. Like if there's even $1 MFT entry, even if there's a one file entry, shouldn't I be able to find it? Shouldn't I be able to do something with it? It should not matter to me if I'm doing forensics or doing something else. I don't want to carve. I want the entry. I want the metadata. I want this value of the dates and times. So I want to get that data. So I'm kind of dead in the water with this particular tool at the moment. Now, here's the funny thing is they make a tool that searches $file entries. And so I called Runtime and I asked them for a way to get that data into this program because this program crawls through existing stuff when it works. But they have one that searches for content when it doesn't work. And so I'll show you that in a second and how we can get to that. So let's pretend none of this works now and I'm on our oil rig and it's going down and burning and I need to do something quick. So close this program. Now let's pause in time on our burning rig for a minute. Let's assume we looked at the same file in FTK Imager because that's what a lot of tools, a lot of FTK or in-case images would show exactly what FTK Imager will do. So open up FTK Imager again. Now we are going to open that file. Make sure you have the other tool closed or the file will be locked and you won't be able to have access to it. So you hit File, Add Evidence. We're going to look at an image file. And I want you to go to the same file, NTFS Quick Scan. So you say Browse, your C drive, data recovery images, NTFS, NTFS quick scan, and open up that DD image and say OK. Everybody okay? You guys good? And you all got the same thing, right? If you expand the little pluses, right, you have that same answer, right? Unrecognized file system. So all the stuff we would normally do to parse stuff, to look at stuff after recovery. Now, the funny thing is, if you look at the first sector, you can see it's a boot sector. It has 55AA. How many partitions does it have? 1. NTFS. You have all the same data. You have all the same thing. It knows you have one. And remember NTFS, HPFS. HPF is OS2. That's why it says that. Because NTFS and HPFS are equivalent except for one block. So unrecognized file system, I can't parse it. I can't do anything. The only thing I could do right away is say, well, crap, does it have data on it? Because this tool doesn't carve. All this tool does is give me a way to image it, review it, if it knows what to do with it. And that's pretty much what happens in Encase 2. So, but you can scroll down and you can say, hey, look, oh yeah, there is data. And then you could even quickly say, oh, do I have FFD8? Do I have a picture? So do I have some real data? So there is data. You can see a lot of data, right? All right, but these are all fail. These are fail, fail, fail. And carving is not sufficient. So close. Close all of that. Let's start fresh again. Now, I'm going to try to do this as quick as possible because if this oil rig is burning down, I know it's taken me a long time to explain it, and I know we're clicking on a lot of tools. But in reality, if I did this in real life, I'd be done 25 seconds, maybe. I could do the whole thing in 25 seconds. Now, I'm not making this crap up and just telling you as we're going. It is actually printed in the book. I have combined 3 or 4 labs together, and all the stuff that we just did, every one of them, is already in the back of the book with screenshots and all the words I just said. Okay? And the video. All right, next. So the tool that they have that can actually do a search for MFT entries does a lot of other stuff on purpose. And so the one that I'm going to say is get data back for NTFS. That tool right there, execute get data back for NTFS. Now, I'm going to show you, here's the other thing. I don't care what tool you use, but start thinking about what the tool does. If your tool, kind of like we did in Windows, when I right-clicked on C drive and it immediately came up and told me how much free space is, my mind goes bitmap. There's no way it could have calculated it any other fast way. It had to have been from the bitmap. If I say crawl through directory structure and it counts them all, it's touching every MFT entry as it goes. So it's going through the directory structures according to what I pointed to. So you start thinking about those things as you go. It makes a difference because my job is about speed. Even in forensics, my job's about speed. So whether it's data recovery or forensics, I only have a couple of hours to do something. I want to make money as fast as possible, and I want to get the job done and get out of the way. That's really what I'm looking for. So time is money. So here's what I'm going to say. Ignore whatever this screen says. This is for dummies. Just hit next. Now, here's what we're going to do. We're going to mount the image we were just looking at. So you'll see on this list, there is an item called Image Files, Load More. I want you to go load the same one we were just looking at. So hit that, hit Load More, go to NTFS Quick Scan. You're going to have to change file types to all, and then you'll have that DD image again. Same one that we did before. Everybody happy? Yep. All right, so go ahead and say open. All right, now before we do anything else, you can expand it. You can see it knows we have an NTFS partition. It knows it's 37 gigs. Now, before we do anything else, speed is very important to me, so I don't want to waste a lot of time. And don't click the buttons I'm about to click. I just want to show you something before we do anything else. Because the defaults, I've changed the defaults. The defaults for this application, this is what everybody else does, right? They click every button that's available. You should never click these MFT entries without knowing what you're doing. But they click every button available. They click OK. They say go. And then you wait. You wait and you wait and you wait. And I know this is a small drive, so maybe we'll be done in 10, 15 minutes. But if this was 6 terabytes, a RAID array, this is a month. This is a week. Like, why should you wait all this time to know if you're going to be successful, only to wait for a tree and then go, oh my God, that didn't work, let's go back and do it again. That's what everybody does, right? They do that, and especially if they're doing RAID arrays. If they're doing RAID arrays, they set it up, they run the tree, they wait for it to finish, they extract some files, and they go, oh, that didn't work. And then they go back and they do it all over again. And that's why it takes them 2 weeks to do it, as opposed to 45 minutes. So this does take a lot of time. It's parsing a lot. It's doing a lot. So let's think about this for a second. I'm going to stop this. I don't need this. I'm going to stop it. We're back here. Hit the option button and uncheck that box that says quick scan. And then the rest of them should be blank for you, right? So make them all look like this. Let's get rid of all of this. Everybody good? Let's talk about these for a second. In every tool, they name it something different. In our studios, they're going to call it something else. And it's going to be similar, but you can figure it out pretty quickly. And you need to think about it and figure out what the items are. When you know how to use your tool and you know how to use it fast, you'll be better than everybody else. I promise. Just like if you know how to read hex, you know how to use their tool, you know where the things are. You know, if you use Encase and you know where the button is in version 7, it's not as good as it is in version 6, but it's still, you know, you'll be faster than I'm going to be in version 7, because I'm not going to be fast in version 7 because it sucks. But outside of that, all right. So the first one, deleted file recovery. What does this mean? What does each item mean? What does recovered deleted files mean? What do you think that means? Actually, it won't. Nope, because when it's deleted and it's in a trash bin, that's actually having to parse info2 files or $I files for it to be able to see it. So those are actually just considered real files in the trash bin. It actually won't do that because it. I don't even think any of them do it. Yeah, right. And those are real files that still exist.
But they don't. That's not what that's.
No.
I was just guessing.
No, that's a good thing. But you're actually right from a standpoint of disappointment. I just all of a sudden realized how disappointing all the software is that exists, because they're all bad. Not a single one of them actually goes in and says, well, in my trash, what do I really have? And let's show it in the real name. I don't think any of them do it, if I can recall. I think Encase does. I think forensic software does show it, but I don't think anybody else does, surprisingly.
Would that mean looking for files in unallocated spaces?
Nope, not yet. And the reason why is, so if it knows it's deleted, you have to assume right away, if it says it's deleted, then it knows it's deleted. How does it know it's deleted?
Finds the record that's marked as deleted.
Yep, it finds the entry in the MFT record that says it's deleted, which means it still normally exists on the disk. It doesn't have to, because this is the weird thing. You delete a file, and it has a pointer to a cluster, and the cluster's over here. Well, now you change your bitmap, because now it says it's available in the bitmap. So that sector is now available. You add a new record and overwrite it with a long file, it's going to cross over that cluster, and the one that still has a pointer that hasn't been removed yet points to a chunk of that file. So it's potentially possible it still exists. It's also potentially possible that what you're going to get is something else out of the middle of another file. So you don't really know. And that's why some of those files are bad, because they're pointing to the middle of something else that overwrote it that had nothing to do with that file. Okay? But it does know it's deleted, so it would be from an MFT entry where there's a flag. Okay? Second thing, allow duplicate file names. When would we have duplicate file names? Why would we have them?
Files that were in different folders. Same name.
It won't be in a different folder only because, well, because if it's in a different folder, you can actually have a file with the same name in a different folder. You can't have it in the same folder, right? Why would you have them in the same folder?
But it's saying allow duplicate, meaning when it recovers it can recover 2 files with the same name that were the original.
Backups.
Like
They'll still break them up by folder, though.
the master, like going back, if you cannot get one of it to work, you can take the other file too.
Yeah, there's a situation where if you have So like Word documents as an example. A Word document makes a temporary file, renames temporary file, makes the new file the old file's name. And you might have an old deleted file or a temp file that they're not really going to be the same name today, but they were once upon a time because they used to use a static name. Now they actually use a randomizing key from a timestamp or something, and they randomize it. But there are times where a tool or software makes a file the same name and deletes the old one as it replaces it with the new one. So you might have two in the same folder, but these will still be done by folder. So you can still have them in the same folder, only because I know what this tool does, not because you're wrong, but because this tool is going to still divide them up by file name. Directory Opus can do it regardless of file. There's a way to do that in Directory Opus, actually. So if a user's system crashed, what do they want back? Do they normally want back deleted or unallocated files? If it just crashed, let's say your system had a bad sector and the system crashed, what do they really want back? What do you? They want what?
The allocated files.
They want the allocated files. They want the ones that already existed. They're not really most of the time asking for the stuff they deleted or the stuff that's rare actually. It's like 2% of my jobs. The percentage of my jobs is normally, oh, our system crashed, we just want back what we had. We don't even care about the deleted files. We don't care about unallocated. They want allocated space that was real files, not the ones they deleted because they really meant to delete that file. But the system went wrong and a sector died. So in most recoveries, would we need either one of those? In the majority of recoveries for existing drives where there was damage, we would not need those at all. And the reason we don't need them is because they actually deleted them and they don't care if it's gone. Now, we can always rerun it later if they wanted them, but generally speaking, I will tell you from experience, they don't want what they already deleted or their temporary files. The only chance that I want these is I have a Word document that actually is on the drive that is corrupt and a backup file might actually still contain the data. And I could go back and get the backup file or the one that was left there with an alternate name might actually contain the data. Right? Yep.
What if, like, in a situation, you have a job where maybe an employee, on his or her own system, left and deleted stuff, and the organization wants you to bring those data back.
Yeah. Now, in those cases, though, your damage is probably not to the drive. Like your damage isn't, the drive isn't damaged, right? No. So if you have a damaged drive, you probably only want allocated. If you have a not damaged drive, you probably have the situation you're describing where a sysadmin left and formatted his hard drive and deleted everything, and then you might need that, right? But that's a judgment call on your part. I would say the majority of recoveries in my world, in the data recovery side, are all not purposeful, and the ones in forensics are purposeful. Like those are normally two different things. And most of the time when somebody says that, if they say that to you and you're working on your own and you're out in your own company and somebody says that to you, what your next question should be, are you going to use the information I'm going to provide to charge the person with a crime, or are you going to go after them or sue them? Because that's probably what's going to happen. If a sysadmin leaves, deletes all the data, the company calls you and say, hey, my buddy left the company and he deleted everything, I want it back. Then the next thing that's going to happen is after you prove he deleted the stuff and you give it back to them, they're going to file a charge against him. That's what happens. That's a forensics job. It's worth more money. It's worth a good bit of money because you're also going to be bothered a lot for reporting. They're going to want to know what files did he delete, when did he delete them, how did he delete them, what still exists, what doesn't exist, what did we not recover that was damaged, because that's the actual loss. If you recover a file, then the only thing, this is a weird scenario, right? If he deletes the file and leaves, and you recover the file and give it back, the only thing most of the time they're going to win in court is the amount of money that it costs for you to recover the file, because now they have no loss. You recovered it. If they have a loss, then there's a value associated with the loss of the file. So when they're suing them and you say, oh, he had these 6 files and they were lost, and they were spreadsheets that showed all the accounting data for every customer, now they have a loss, and that's what they want to know. Understand my point? So just keep that in mind as you go through that process. Okay? So, but in a damaged drive, you probably don't want these. They're probably looking for the real files. We already went over this. What's excessive search? File system.
Looks everywhere for partitions.
Every single sector for a partition, and it will touch every sector without you getting any benefit or a copy at all, which is bad. If you ever run a piece of software that touches every sector on the drive for no benefit of a copy or anything else, then you're doing the wrong thing. That's my opinion. You should never do anything that builds a tree or does it on the original. If you can touch the MFT and you can read the MFT file entries, you don't need to touch every sector on the drive. You only need to do that if it's unallocated space, right? So what if you check the box, it does every single sector. If you do not check the box, what does it do by default? Yeah, it does cylinder boundaries. Yeah, it would have been top platter in reality, but today it's a numeric value that just goes across this block every 8 megs looking for it. Okay? So we don't need that because we don't need to find our partition. What we need to find is MFT records, right? We don't care about the partition. I don't care about the partition at all. I care about the clusters. Okay? Everybody fine there? Okay? Now you know the answer. What's this one? Raw file recovery. What's a raw file? What? You said it 5 minutes ago. What is it if it's a raw file? Yeah, it's an unallocated file. So unallocated space that the MFT entries do not know, that do not fit in MFT or do not fit in the deleted recovery, this is raw, so that's carving. Those are the files that have to be carved. Now what you don't see is inside of all pieces of software that do carving, they have a table, and the table has headers and footers in it. They have a way to define how we're going to carve a file out. Every single piece of software does. You can't see it, it's not visible, but when you check that box, it's actually going to say, I have this extensive list of 975,000 files, and I'm going to try to carve those files out. And let's say somebody writes a new version of QuickBooks tomorrow, and QuickBooks has a new header. This piece of software will not know the new header. Until an update is provided that includes that new header, it will not find the file, ever. You guys understand this, right? If it doesn't know the header and the footer, it doesn't know it. So if I make a new JPEG format tomorrow that starts out with FFD10, it's the FFDA, by the way. Right, that's awesome. D10. Hey, that's going to be our new motto, the FFD10. It sounds pretty cool. It sounds like a soldering event. So, recover lost files. This would be carving. Do we need to carve? Most of the time, if we have a damaged hard drive and they want back what they already had allocated, will we need to carve? Nope. Because if we carve, what does it have to do? It has to touch every sector on the drive and look and see if you have a header, at least at every cluster, but it's probably going to look at every sector. I mean, you can actually watch it do it. I mean, it takes a while. You saw it do it a second ago, because if I didn't do anything else and I just said go, well, that's what it's doing. These are carving. These are, and you'll see it go by. Word document, spreadsheet, file, the list goes on, right? So that's what it's physically doing, is looking at headers in those sectors and trying to figure out what they are. Directory structure, blah, blah, blah. All right, everybody get the point? So this is going to take a while, right, if I let that happen? So back to the options. All right, so MFT options. Now, as a person who doesn't know anything about computers, when they come in here and they go, oh, I lost a file, I bought this product, and then I plug this in, that's really bad for them because they're like, MFT? Like, they have no idea what that means at all. Like, there's no explanation in any way, shape, or form that they even know what this is. So it's good for us. It's bad for them. I like it because it confuses them. So MFT options. Use valid MFT only. What does that mean? When would I have an invalid MFT?
Maybe corrupted or missing.
Corrupted or missing? When do I have a valid one? What's a valid MFT?
Not corrupted.
Hmm.
I'm just guessing.
I mean, it could still be corrupted because we're doing this, right? It could still be corrupted. I know. I mean, I kind of fish in my questions, and I know it's a little abusive, but
So the valid
Keeps you
is,
interested, right?
it does. It keeps you guys interested. It keeps you thinking, at least.
So the invalid is in unallocated, and the valid is unallocated. unallocated?
No.
Okay.
The reason I say no is because unallocated, the only way you can get it back is carving, because there is no MFT entry, so you don't know where it is. So you don't know anything about it. But valid and invalid. So
Applying to the partition only that you're trying to search. So if it's going through an NTFS partition, it's only going to get MFT stuff from an NTFS, maybe? Or, I don't know, I'm just throwing out some stuff.
yeah, no, everybody's throwing stuff out now. So the situation that creates a valid MFT file is reformatted your hard drive. If you reformat your hard drive, right, you have entries for MFTs that do not belong to the current one. And that would be, the current one is valid. So if I reformat the drive, what happens is there's something called data length for every parameter. And so it'll say, how many entries do I have in the valid MFT? Oh, I only have 35 files. So it doesn't go out there and look at all those other MFT entries that are sitting on the disk because they don't belong to this copy. Right? Those are invalid. They don't belong. These are valid and they do belong. So if I reformatted the hard drive and I check that box, I'm only going to get back the reformatted content. I'm not going to get anything from the unreformatted drive, the previous version, right? Because there'll be two copies. When you reformat a drive, you'll have one copy of the user folder. In the previous one, there's another copy of the user folder. And you'd have two side by side. Bob is over here, and Christy is over here. Does that make sense? If I check that box, I only get the reformatted content. If I don't check that box, it does every file record and every index record. It searches for dollar. This is why I said, I knew they had this option, and they did not have this option. This option was not here several years ago when I asked them to add this. So, in all the stuff, because you know me, what I would ask for, right? I would say I only want one button, and if I click it, I want it to give me my files, right? That's what I want. So that's what I told them I wanted. I said I want a quick scan. I want one button that will then parse MFT records and nothing else. So you saw I clicked the button before, and it did all this other stuff, right? So quick scan, what do you think quick scan does? Only searches. It searches not only valid, it does search for invalid. It only searches for file records and index records. So it'll search for all of them, whether they're valid or invalid. It doesn't matter. I'll search the whole thing for all of those records. There's only a certain amount of space that's allocated for MFT records. So there's only a certain amount it will find because there's a pointer that will point to it.
Doesn't quick scan also only go through certain files? It kind of skips ones that aren't like main file types, or is that?
No, it does all of the records that are dollar file, dollar index. There's also another set that's called bad, which it does not process, but it does do all the ones that are on the drive, right? So watch. Click quick scan and do nothing else. Because you saw a minute ago, if I ran this, it would run for a half hour, 15 minutes, whatever. So I want to be as quick as possible. Now I will point out this last box, bad sector strategy, the retry on each sector, this actually tries to do ATA commands to the drive to say, give it again, give it again, give it again. Whereas the other one is just basically skipping and doing the API calls. So this is one of the few tools that kind of goes around the bad damage on the drive and maybe retries to try to get it further. So, all right, so we're gonna say okay on this, right? And then we're gonna say next. Now, you saw how quickly that ran? Like that was spontaneous, right? That was instantaneous. It located the MFT, it scanned all the MFT records. You can see it found them. It knows how many that there are. And then, now there's a chart down at the bottom. If I had scanned the whole hard drive, you would know the difference between files that were carved and files that were already in existence in the MFT. Because it will tell you a percentage that would be similar. So you should be like around 70% of the drive would be the same. And there'll be some that will be unallocated. So that's why it's 0, because we didn't scan it. So there's no file starts because those are headers. We don't have any because we didn't scan the drive for a half hour, right? Now, here's the other thing. The tool that I was using was NTFS Explorer, which would have been my preferred tool. I didn't ask them to do anything extra here in the tool. All I wanted them to do is find the $MFT records because they already had them, right? So there's a button at the top You see the button that says Explorer? Click it. Now remember, we're looking at the same image we just looked at in the same tool. It found the MFT records and passed them back to my other tool. So now I have a virtual $MFT that exists that I could export, I can save. Because here's the thing, in damaged data, this is extremely important for forensics people, not quite as important for data recovery people. But I want to make sure you understand the distinction here. You have raw data on your drive. So if you find a JPEG, it does not have the file system's date and time. It does not tell you when you copied it to the hard drive unless you have the MFT record, right? So when you extract this data, let's say you carve the data out, you might have the JPEG, but what keeps track of that if you want to report it? If you need to tell somebody what you have, that's the file that tells you what you have. Do you understand what I mean? So I have to save this file because there's no way for me to reproduce this corruption and give it to the other side. I'm not going to repair this and hand it back to them and say, here you go, here's my handy forensics repaired drive, and I did all the work for you. You have to save that file because that file is your proof. That's your Excel spreadsheet. Understand? Now, if you look on the menu, just so you can see really quick, go to the Go-To menu. See all my options? I now have a root directory. So hit the root directory. This is, and I can prove it to you, see the image right here? I just passed the link for the file to this tool, and I parsed the MFT entry, and I now have all the stuff that Encase, FTK, even its own tool did not do before because it did not scan for MFT entries. And a lot of the other tools don't do them either. They just carve files and make a new setting. They don't rebuild it. Do you understand what I mean? It's just clear. This is really awesome, actually. In my mind, I have stuff I do this with all the time in forensics where I have to rebuild a true living system that will do this as an explanation. So I actually have the real folder structure, and the guy who called me about this one, his name is Mark Basinger. So if you click on the documents and settings, now I dummied up this drive, so this drive is dummied up on purpose with damage and a bunch of other stuff. It's really hard to make it. But you'll see Mark Basinger. So Mark Basinger is the guy who wants his recovery. So if you actually look to the right, you can say save, and all Mark cares about is his stuff. So if you want to save, now I'm going to show you the rest of the process. Did you click on it? You okay? It's documents and settings. Documents and settings. Everybody good? And so what I'm going to do is, this is the part of the tool that I don't like. I have to hover over the right word to figure out which one it is and then move away from it, or I can't figure out which folder I'm trying to copy. Understand? So I'm going to come over from Mark Basinger, and I'm going to say right there, I'm hovering over it, and so Mark Basinger, Mark.Basinger, over the save button. Everybody good? Now what I would do is, in real life recovery, anytime, every step of the way that I make, because I may do multiple passes. I may do pass 1, pass 2, pass 3, and then I may give them a merged copy, or I may, if I can figure out the layout of it, I'll give it back to them. But they may only want the Mark Basinger folder. So I click Save. Now I'm going to show you how I do my work. The key is short directory structures. That's the first thing. Because you have a limit to how far you can copy stuff unless you use UNC encoding. And I'm not going to go into that right now. But UNC for network pass will take away that limit. So I'm going to, on my C drive, I'm going to make a recovery directory, but I'm going to call it RV. That's what I would call it, RV. Okay? So I'm going to come over here to the side, and I'm going to click, hey, I'm going to go to the root of whatever drive I'm recovering it to, and I'm going to make, a folder called RV. And that will be the root of all recoveries that I do on this system. Okay? inside the RV, I might, because every single drive that comes in my office is numbered and has a name that's associated with them. And sometimes I have repeat clients. So I have like, if Intel sends me a drive, I want, a numeric number for Intel, and I might have a different manager in each department at Intel that might send me something. So I'll have, whatever department and the name. So sometimes I'll name them longer, and then if I run into a problem, I'll shorten it. But the number is all I really need to associate with it. But it helps me when I have a client list, find it really quick. When it says 749, I'll just go to 749. Now we have over 10,000 at this point because we do a lot of drives. So I'm going to make a folder, and this particular one is going to be, let's just say it's at 478, and then, Intel, whatever. So I'm going to make a folder. I'm going to say open, and then I'm going to save. Now the next thing is I'm going to do subdirectories. I want all the subdirectories to be copied as well. So this is just a click fest at this point. But when I do this, I want you to notice one really cool thing, because very few tools do this. All the other tools work in the API, and they require a call to the API. Well, this one works on LBAs and clusters. So this tool crawls across those safely. And so when I say OK, and it starts to copy the data, watch what happens. If you can read it fast enough, you can see it reassembling all of the clusters. So this is doing the groups of clusters in order. Instead of just flashing all over the disk and doing everything it has to do, it's following the chains and only touching those sectors. It's not touching the Windows System folder. It's not touching the program file directory. It's only touching Mark Bassenger stuff. So I'm safer. And if there's corruption in the Windows System folder, I don't have to touch it. So I extract all this content to a folder. Then I make a list and say, hey, I've recovered all your data. If there's any damage that's left, and like for instance, I'm going to get a perfect recovery out of this. I'm not going to have any damage in these sectors. The damage is in the OS. It's in the beginning of the disk. It's not in his users folder. So I'll know this already when I'm done. And if I have damage, I'll tell him, oh look, 10% of the files are damaged. Do you have something specific you're looking for? I will look and send you a Xerox or a copy of it so you can say, yes, I want your recovery, or no, I don't want your recovery. I hate to say you can't trust your clients, but you have to be careful what you give them. Okay. Well,
What did that do wrong?
you guys have a faster machine than I have. My machine's older, actually. My machine's been, I've been teaching on this machine for almost 8 years now. So the ones that you guys have are newer. So it doesn't matter. Anyway, or maybe you did the wrong directory. Anyway, it doesn't matter. The whole point is that's what you do. And I track it by number. The paperwork has a number. I email the guy with the number. The guy responds to me, says, yes, I want the recovery. How do we get a drive? And then the rest of the business practices.